Okay, so now that we have learned what radian measure is, we need to figure out a way to convert between radian measure and degree measure. So you're used to degree measure. That's familiar to us. We've been working for it for a number of years. And we just learned this formula here, S equals theta r, which gives us a relationship between the radius r, the arc length theta, the angle measure theta, and the arc length s. So with this relationship here, we're going to apply that to a circle and using degree measure, and we'll be able to convert it into radian measure. So let's see how that works. If we take any circle, there's our circle. There are some basic things that we definitely know about circles. One of them being that this line here through the center, that's called a diameter. And we know if we were to look at this angle of rotation right there, we can say with total certainty that the measure of that angle in degrees would be 180 degrees. Okay, real simple. So we see we have a 180 degree angle. What we want to do now is figure out what does that measure in radians, and then we'll have a conversion factor to go from 180 degrees to however many radians that is. So let's start with the basics. We know that this arc, if we went halfway around the circle, that arc length, S, is half of the circle's circumference. So we know S would be equal to half the circumference, C. But we all remember that the circumference of a circle is equal to pi times the diameter, or diameter is twice the radius, so maybe you remember it as 2 pi r. So if the arc length is half of the circumference, then this arc length S is equal to half of 2 pi r. The formula for circumference tells us circumference is 2 pi r. We substitute 2 pi r in for C. Now we can see real quickly here that the 2 and the 1/2 will cancel, and we can see that S is equal to pi times r. In this particular circle, this arc length S is equal to pi times the radius. Half of the circle is equal to pi times the radius. But we just learned up here that in all cases, S is equal to theta times r, where theta is in radians. So if we have two different expressions that are both equal to S, we know then that pi r has to be equal to theta r, and that would mean that pi is equal to theta if we just divide out the r. So pi is equal to theta, where theta is measured in radians. Actually, we don't need the parentheses. So in this semicircle right here, pi is equal to theta radians, but we also know that that angle is definitely equal to 180 degrees. So what that means, actually this is a little confusing here. What I mean to say is theta is equal to pi radians. The angle measure is pi. Theta is equal to pi, so this is pi radians. We see two different measures for theta. This tells us that 180 degrees is equal to exactly pi radians. And here is our conversion factor. So if nothing else clicks about everything I've said so far, this is the important thing to take home, that 180 degrees is exactly equal to pi radians. You can watch this back or watch other people's derivations of this, but we must understand that 180 degrees is equal to pi radians. Okay.